Every year, the world produces more than 50 million tons of electronic waste. Phones, laptops, TVs, batteries. You throw them away thinking you did the right thing. But most of it is never recycled where you live. It leaves rich countries in legal shipping containers and ends up on open land where people burn cables with bare hands just to pull out copper. Your technology looks clean on one side of the world. On the other side, it turns soil toxic, water unsafe, and human lives into disposable parts of the system. At the edge of a city that never appears on tech company maps, a boy sits on the ground before sunrise. He is not looking for food. He is breaking open a discarded laptop with a stone, because he knows where the copper usually hides. His hands are already dark with soot that never fully comes off. Around him are piles of electronics stacked higher than his head. Phones from offices, monitors from hospitals, routers from schools. Many still carry asset tags and barcode stickers. All of them arrived here under the same label, second-hand goods. A few meters away, an older man burns a bundle of cables in a shallow pit. The plastic insulation melts first, releasing thick black smoke that stays low in the morning air. He waits until only bare copper remains, then pulls it out with a metal hook. By weight, it is worth just a few dollars. Enough to buy food for the day. Not enough to stop. Nearby, a woman sorts circuit boards into 3 piles. Green boards go one way, brown boards another. The smallest pile is the most valuable. Those will be soaked later, stripped for traces of gold. Acid is reused until it weakens, then poured onto the ground behind the houses. Someone mentions a container that arrived during the night. Hundreds more devices. Office desktops. Old servers. Printers that still smell like dust. The shipment cleared customs without trouble. The paperwork said reusable. No one here expects them to work. They are opened anyway. This place is not a recycling center. It is the end of a decision chain that started far away, in air-conditioned rooms where devices were replaced on schedule. Somewhere else, someone upgraded their phone. Somewhere in between, documents were signed, stamped, and filed. This ground is where those decisions finally become physical. Nothing here is accidental. The waste did not drift here by mistake. It followed a path that has been used for years, protected by rules written far from the smoke. The boy does not know those rules. He only knows that when one pile is gone, another replaces it, and the work begins again. By the time that laptop reached the boy's hands, it had already traveled farther than most people ever will. Every year, the world generates more than 50 million tons of electronic waste, and the number keeps climbing. Phones replaced every 2 years. Laptops every 4 or 5. Servers in data centers even faster, often scrapped in bulk after a single upgrade cycle. This is now the fastest growing waste stream on the planet. Less than a quarter of it is formally recycled. The rest moves through routes that look orderly on paper and chaotic on the ground. In Europe, companies upgrade entire offices at once, pallets of still-tagged desktops leaving buildings overnight. In North America, retailers collect trade-ins by the thousands, promising responsible recycling. In East Asia, factories clear inventory as models change. The volume is enormous, but the pattern is familiar. Collect, label, ship. On paper, much of this material is not waste at all. It is recorded as reused, refurbished, or donated equipment. A container might be declared as carrying second-hand computers for education or small businesses. That single phrase opens doors. Inspectors do not test every device. They cannot. A random laptop turns on. A monitor lights up. That is usually enough. Broken units sit deeper in the container, invisible until arrival. In the exporting country, the shipment counts as reuse. In the receiving country, it becomes something else within hours. In ports across West Africa, South Asia, and Southeast Asia, the same routine repeats. Working devices are separated quickly and sold in local markets. The rest are stacked, stripped, and burned. The scale shows up in destinations as much as in volume. In Ghana, large quantities of imported electronics funnel toward informal processing zones where soil samples now show heavy metal levels far above safety thresholds. In Nigeria, used electronics markets double as dumping grounds, where unsellable devices pile up behind stalls and spill into nearby waterways. In India, dense neighborhoods handle dismantling inside homes. Acid baths reused until they lose strength and then poured into shared drains. In Vietnam and Thailand, temporary crackdowns shift routes rather than reduce flows. When one port tightens controls, shipments reroute through another. The waste does not stop moving. It changes direction. What makes electronic waste different from other trash is what it contains and how it is treated. Inside every phone and circuit board are valuable materials: copper, gold, silver, palladium. Small amounts per unit, but enormous totals when multiplied by millions. At the same time, those same devices contain lead solder, mercury switches, cadmium, and flame retardants. In regulated facilities, these substances are contained. In informal yards, they are released. Burning cables fills the air with toxic smoke. Acid baths leach metals into soil and water. Ash settles into fields where food is grown. These are not isolated accidents. They are routine methods because they are cheap and fast. Economics keeps the flow steady. Proper recycling requires specialized plants, trained labor, and strict controls. Costs more than exporting. A single container can move thousands of devices across oceans for less than the price of dismantling them legally at home. Brokers earn margins by moving volume. Informal recyclers earn by extracting metals at minimal cost. Buyers upstream purchase refined material without asking how it was obtained. Copper stripped from burned wires looks the same as copper from a certified refinery. Once melted and sold, its history disappears. In some cases, those metals re-enter the very supply chains that produce new electronics. Yesterday's waste becomes today's raw input, cleaned of context. Statistics alone cannot capture the full scale. In many receiving regions, entire communities depend on this trade. Children sort components because their hands are small. Adults specialize by task: screens, cables, boards. Middlemen coordinate payments and transport. Local authorities tolerate the activity because it provides income where few alternatives exist. National governments hesitate to enforce bans that would eliminate livelihoods overnight. Exporting countries point to compliance documents. Responsibility fragments at every step. Each actor handles a small, defensible role. No one owns the outcome. From a distance, this looks like a logistics problem. Close, it is a transfer of risk. Environmental damage, health costs, and long-term cleanup are shifted away from consumers and manufacturers and concentrated in places with the least power to refuse them. There is no single disaster moment to mark the scale. No collapse to film. Only accumulation. Year after year, devices move along the same routes, through the same ports, into the same neighborhoods. The numbers rise, but the system stays familiar. Electronic waste has become a predictable feature of the global economy, growing quietly alongside the devices that created it. Electronic waste exposes a contradiction built into modern technology. The cleaner devices look where they are used, the dirtier they become when they are discarded. A smartphone produces no smoke, no waste, no visible pollution while it sits in your hand. The damage begins only when it stops being useful. At that moment, the problem is no longer about technology. It becomes about distance. Safe recycling demands time, trained labor, sealed facilities, and strict controls. In many wealthy countries, dismantling one device properly can cost more than the metals inside it are worth. Exporting it avoids that cost. What is presented as efficiency is, in practice, displacement. This paradox survives because of a thin legal line between waste and goods. If a device is classified as hazardous waste, it triggers inspections, permits, and restrictions. If it is labeled as reusable or second-hand, many of those barriers fall away. The difference can be a single line on a form. A cracked screen does not automatically make a device waste. A missing battery is often ignored. Exporters know how to load containers so that a small portion of working devices sit near the doors. Inspectors power on a few units, see screens light up, and move on. The shipment passes. Once it arrives, the classification no longer matters. Devices that cannot be sold are dismantled within hours. The paperwork has already done its job. Responsibility has crossed the border. Design choices deepen the paradox. Modern electronics are not built to be repaired easily. Batteries are sealed. Components are glued. Screens are fused to frames. Software updates slow older hardware. Repair manuals are restricted. Spare parts are limited or overpriced. For consumers, replacement is faster than repair. For companies, rapid turnover drives revenue. For waste systems, this guarantees a steady stream of devices that are technically goods but practically unusable. Many units exported as reusable were never likely to be reused. They were waste long before they left the warehouse. The system depends on this gap between what is claimed and what is possible. Sustainability language adds another layer. Companies promote take-back programs and recycling pledges. Consumers are told to dispose responsibly. Collection points fill with devices, and the act of dropping something off feels like closure. But responsibility ends at collection. After that, devices enter chains optimized for cost, not care. The environmental burden does not disappear. It relocates. A clean recycling statistic in one country often corresponds to increased contamination elsewhere. The greener the report looks at headquarters, the darker the ground becomes at the endpoint. Material value keeps the contradiction alive. Electronic waste contains copper, gold, silver, and other metals that are expensive to mine. Recovering them in regulated facilities requires advanced technology and oversight. Recovering them informally requires fire, acid, and labor. The second option is cheaper. Buyers further up the chain rarely ask how materials were extracted. They buy based on purity and price. A bar of copper refined from burned cables looks identical to one produced in a certified plant. Once metals are melted and sold, their origin disappears. In some cases, these materials flow back into the same supply chains that manufacture new electronics. The waste of one generation becomes the raw input of the next, stripped of its history. Policy reinforces the paradox rather than resolving it. International agreements exist to restrict hazardous waste exports. On paper, they are strict. In practice, enforcement varies widely. Some countries lack the resources to inspect shipments thoroughly. Others prioritize trade speed over environmental risk. Exporting countries rely on documentation to show compliance. Receiving countries face economic pressure not to disrupt flows that provide income. Everyone follows the rules as written, while the outcome violates their intent. The paradox is not simply regulatory failure. It is the result of incentives aligned to keep costs low and consequences far away. At its core, electronic waste reveals how modern economies handle inconvenient outcomes. Consumption is encouraged. Replacement is normalized. Disposal is hidden. When a device becomes obsolete, it does not reach an end. It enters another phase of value extraction, one that operates out of sight. The system cannot slow down without questioning constant upgrade cycles and planned obsolescence. As long as growth depends on replacement, waste will grow alongside it. The paradox persists because it serves too many interests at once. Consumers get convenience. Companies get profit. Governments get plausible deniability. The cost settles elsewhere, in places with the least power to refuse it. That is why, despite better technology and louder promises, the problem continues to expand. Expanding. The electronic waste system works because it looks ordinary at every step. It begins in clean spaces. Offices replacing computers on schedule, hospitals upgrading equipment, data centers clearing racks after a refresh cycle. Devices are collected in bulk under contracts labeled asset recovery, take-back, or recycling. Pallets are wrapped. Serial numbers are logged. Nothing looks illegal. From there, the devices are sold to brokers whose real product is not electronics, but paperwork. Their job is to move volume while keeping shipments inside the category of goods. Waste triggers controls. Goods move freely. One word on a form decides the route. Once classified, containers are packed strategically. Working devices are placed near doors. Broken ones go deeper inside. Export declarations describe the cargo as second-hand equipment or donations. Inspectors, when present, rely on spot checks. A laptop turns on. A phone lights up. That is often enough. Testing thousands of units would take days. Ports are under pressure to move cargo quickly. Delays cost money. Containers move. From Europe, North America, and East Asia, shipments head toward familiar destinations. Records show repeated routes to West Africa, South Asia, and Southeast Asia. When scrutiny increases in one port, shipments are rerouted through another. The system does not stop. It adjusts. Arrival is where the machine splits. In receiving countries, devices are unloaded and sorted within hours. Anything that still works is sold in local markets. This creates visible reuse and helps justify the trade. The rest, often the majority, is dismantled. In informal yards, workers crack casings with stones or hammers. Screens are smashed. Frames are bent. Cables are stripped and burned. In some places, circuit boards are soaked in acid to release gold flakes. The acids are reused until they weaken, then poured onto the ground or into drains. Smoke from burning insulation fills the air. This is not treated as an emergency. It is routine work. In places like Agbogbloshie in Ghana, Sealampur in India, or informal sites outside Ho Chi Minh City, entire neighborhoods are organized around these tasks. Above the yards sit middlemen. They buy recovered materials by weight. Copper stripped from cables is bundled. Aluminum frames are stacked. Circuit boards are graded by color and density. Prices fluctuate with global metal markets, not local health conditions. Workers know roughly how much a kilo of copper will fetch. They do not know where it will go next. Aggregators consolidate material and move it to small refineries or smelters. At this stage, the material begins to look clean again. Molten metal erases origin. A bar of copper refined from burned wires is indistinguishable from copper produced in a certified plant. Buyers further up the chain care about purity and price. They rarely ask how the metal was extracted. Documentation is minimal. Responsibility has already thinned out across multiple handoffs. Examples repeat with minor variations. In Nigeria, used electronics markets operate as both resale points and dumping grounds. Unsellable devices pile up behind stalls and spill into nearby waterways. In India, dismantling often happens inside homes. Acid baths sit next to cooking areas. Children sort components because their hands are small. In Vietnam and Thailand, temporary bans create short pauses, followed by rerouting through neighboring countries. When Malaysia tightened controls, shipments increased elsewhere. When one yard is closed, another opens kilometers away. Enforcement targets endpoints because they are visible. Upstream decisions remain untouched. Money flows quietly through the machine. Exporters save on domestic recycling costs. Brokers earn margins by moving containers. Informal recyclers earn by extracting value from what others discard. Governments collect port fees and trade revenue. At no point does the system require a single actor to accept full responsibility. Each participant performs a narrow, defensible role. Together, they create a chain that efficiently relocates risk. Health damage, environmental contamination, and cleanup costs settle at the lowest level, where legal recourse is limited and alternatives are few. What keeps the machine running is predictability. Everyone involved knows roughly what a container is worth, how long it will take to process, and where oversight is weakest. This is not a hidden conspiracy. It is an open routine sustained by incentives. As long as electronics are designed for rapid replacement and proper recycling remains expensive, the machine will keep operating. It does not rely on secrecy. It relies on distance. Distance between where devices are used and where their consequences appear. The damage caused by electronic waste does not concentrate in one place. It spreads along fault lines where oversight is weak and alternatives are scarce. In West Africa, imported electronics move inland from ports and collect in open processing zones. In parts of Ghana, soil tests taken near dismantling sites show lead and mercury levels far above safe limits. During the rainy season, runoff carries residue into nearby streams used for washing and fishing. Clinics in surrounding neighborhoods report chronic respiratory problems and skin conditions as routine cases. These symptoms are treated individually, but their source is shared ground. The pollution does not announce itself. It accumulates until normal life quietly changes. In Nigeria, large used electronics markets function as gateways. Working devices are sold at the front. Broken ones pile up behind stalls. Over time, unsellable waste spills into drainage channels and vacant lots. Informal burning to recover copper releases smoke that settles over nearby housing. Residents notice that crops grown close to these areas fail more often. Wells begin to taste metallic. The markets remain open because they generate income and because closing them would displace thousands of traders overnight. The waste stays because there is nowhere else for it to go. South Asia shows a different pattern. In parts of India and Pakistan, dismantling happens inside dense residential areas. Families specialize by task. One household strips cables. Another cracks screens. Another handles circuit boards. Acid used to extract metals is stored in reused containers and applied by hand. When it weakens, it is poured into shared drains. Groundwater contamination spreads beyond the households involved. Wells serving entire blocks show elevated heavy metal levels. The work continues because stopping would remove income from entire neighborhoods at once. Environmental damage reduces other forms of work, which increases dependence on recycling income. The loop tightens. Southeast Asia adds another layer. Countries like Vietnam, Thailand, and Indonesia have alternated between welcoming and restricting electronic waste imports. Temporary bans create short-term pauses. Shipments reroute through neighboring ports. Informal processing sites reopen just outside regulatory reach. In rural areas near these sites, farmers report declining yields in fields adjacent to dismantling yards. Rice paddies absorb runoff during monsoon seasons. Fish populations drop in small rivers used for irrigation. These losses are gradual. By the time they are measured, they are already normal. Across regions, the same structure repeats. The most severe impacts settle where enforcement is weakest and dependence is highest. Communities become locked into the trade. Health problems limit mobility. Environmental damage removes alternatives. Children grow up around the work and enter it early. Attempts to intervene often focus on clearing visible sites rather than altering flows. Closing a dump does not stop shipments. Shutting down a yard does not reduce demand for cheap processing. The system relocates. Damage follows. What makes this map hard to confront is its fragmentation. There is no single disaster zone. No moment of collapse captured on camera. Each location shows only part of the picture. A polluted river here. A contaminated field there. A clinic overwhelmed somewhere else. Together, they form a global pattern that is easy to ignore because it is dispersed. Over years, small exposures become chronic illness. Over decades, land loses its ability to recover within a human lifetime. These places are not anomalies. They are endpoints built into the system. They exist because global electronics need somewhere for their consequences to settle. The destruction does not signal a breakdown. It signals balance. Risk is transferred away from consumers and manufacturers and concentrated in places with the least capacity to refuse it. The map keeps expanding, not because the system fails, but because it works as designed. In one community downstream from an informal recycling zone, the damage became visible only after it entered people's bodies. Children began missing school more often. Headaches, dizziness, constant fatigue. Local clinics treated the symptoms without asking why so many patients looked the same. Blood tests were rare because they were expensive. When they were finally done, entire families showed elevated lead levels. The source was not a factory spill or a single accident. It was the ground. Years of dismantling electronics nearby had saturated the soil. During the rainy season, runoff carried residue into shallow wells. People drank it every day without knowing. There were no warning signs, no alarms, just slow exposure. In another case, a dismantling yard drew attention after media coverage. Authorities arrived, fenced the area, and announced a shutdown. For a few weeks, activity stopped. Trucks no longer came. Smoke cleared. Then the work resumed several kilometers away. Same workers, same tools, same buyers. The metal prices had not changed. Demand had not changed. Only the location did. Some workers followed the operation. Others stayed behind, sorting what remained. The closure reduced visibility, not harm. A former recycler described how the work escalated over time. He started stripping cables because it was simple. Then he learned to crack circuit boards and soak them in acid to release gold flakes. Protective gear was available in theory, but rarely used. Masks slowed breathing and cut output. Gloves made fine work harder. When his hands began shaking, he assumed it was exhaustion. Doctors later diagnosed nerve damage linked to heavy metal exposure. By then, he could no longer do the work that paid for his treatment. There was no compensation, no employer to claim against, no record that his job even existed. Environmental assessments conducted years later confirmed what residents already sensed. Soil samples showed contamination far beyond safe thresholds. Vegetation struggled to grow. Livestock exposed to runoff showed signs of poisoning. The land could not be cleaned cheaply. Heavy metals bind to soil. Removing them requires excavation and disposal elsewhere, at costs far beyond what local governments could afford. The pollution had locked the area into long-term damage. Even if all dismantling stopped immediately, the ground would remain unsafe for decades. What makes these moments climactic is not surprise, but inevitability. None of this required secrecy. The pathways were known. The risks were documented. Reports existed long before conditions reached this point. But intervention was always delayed. Exporting countries pointed to compliance paperwork. Importing countries cited economic necessity. Companies highlighted recycling rates without tracking final outcomes. Responsibility dissolved at every handoff. Here, the human story collides with the system at its weakest point. People closest to the waste carry the greatest risk while having the least power to refuse it. Health problems reduce alternatives. Environmental damage removes other sources of income. The trade becomes both the cause of harm and the only remaining livelihood. This is the cost of the system made visible. Not in a single dramatic collapse, but in lives narrowed slowly, long after decisions were made elsewhere. The collapse does not arrive as a single event. It unfolds as a slow loss of function. Land that once supported crops begins to fail. Yields drop without a clear reason. Farmers try different seeds, more fertilizer, deeper wells. Nothing fixes the soil because the problem is not nutrients. It is contamination that does not wash away. Heavy metals bind to the ground and stay there. Fields closest to dismantling sites are abandoned first. Others follow. What used to be farmland becomes buffer space no one wants to claim. Water systems degrade next. Shallow wells draw from aquifers already compromised by years of runoff. During dry seasons, concentrations rise. During rainy seasons, contamination spreads wider. Communities that relied on local wells are forced to buy water or travel farther to collect it. Costs rise. Time is lost. Illness becomes more common. Kidney problems. Neurological symptoms. Developmental delays in children. These effects do not trigger emergencies. They accumulate until reduced health becomes normal. Economic collapse follows environmental damage. As land and water lose value, alternatives disappear. Fishing declines in polluted streams. Livestock weakens after drinking contaminated runoff. Small businesses tied to agriculture shut down. What remains is the recycling trade itself. The same activity that caused the damage becomes the only viable source of income. Dependence deepens. Leaving becomes harder. New generations enter the work earlier, not because they choose to, but because there is nothing else left. Infrastructure absorbs the strain. Clinics see higher patient loads without increased funding. Schools lose attendance as children work or fall ill. Local governments face cleanup costs they cannot afford. Testing confirms contamination, but remediation requires excavation, isolation, and long-term monitoring. These are measures designed for industrial disasters, not informal economies spread across neighborhoods. The damage is too distributed to fix and too expensive to reverse. Authorities document the problem and move on. What collapses is not just the environment. Trust erodes as well. Communities realize that regulations exist elsewhere but not here. Promises of responsible recycling feel distant. International agreements offer no relief on the ground. Each level of the system points upward or outward. Exporters cite compliance. Importers cite necessity. Companies cite policy. The result is paralysis. Nothing changes because no single actor is required to act first. Over time, these areas fall out of development plans. Investment avoids them. Property values drop. Stigma grows. pollution becomes part of identity. Once a place is known for contamination, it is easier to ignore. The collapse stabilizes. Damage reaches a level where recovery is no longer expected. The system adjusts around it. This is not an unintended outcome. It is the long-term consequence of a system designed to keep disposal out of sight. When waste is pushed far enough away, its effects no longer register as urgent. They become background conditions. The collapse does not signal failure. It marks the point where the cost has been fully transferred and absorbed. The devices continue to be replaced. Containers continue to move. And the places that carry the damage quietly fall out of the future. The story ends where it began, with a device that no longer feels important. A phone with a cracked screen. A laptop that runs too slowly. Something replaced without much thought. By now, the path is clear. It leaves the desk, enters a collection box, moves through paperwork, crosses borders, and settles far from the place where the decision was made. Along the way, responsibility thins out. Each step looks reasonable on its own. Together, they form a system that works precisely because no one sees the whole of it. What reaches the end of that path is not just waste. It is the accumulated weight of convenience. The soil that cannot be cleaned. The water that cannot be trusted. The communities that absorb damage quietly while the rest of the world upgrades again. None of this is hidden by accident. It stays out of sight because distance makes it easier to live with. Electronic waste is often discussed as a future challenge, something innovation will solve. But it is already here, shaping places that no longer appear on development maps. The system does not wait for solutions. It continues as long as replacement is faster than repair and disposal is easier than accountability. When a device stops working, its life does not end. It changes location. Somewhere else, it becomes someone else's problem. And as long as that transfer remains invisible, the cycle will repeat, quietly, with every upgrade that feels small at the moment it happens.